Yeah, right, you understand about chapter 3, right? About memory hierarchy and cache. So let me help you. Memory in computer architecture means a physical device used to store data and program. And CPU use memory to quickly get the information it needs to do its task.
So, without memory, what happens to the CPU?
Without the memory, the CPU would not know what to do or what data to use. Do you understand?
Yes.
Okay, we move to the next. And about this picture, can you understand?
I don't know what this picture
This,
about.
this one part of you don't know, right?
Yes,
Right.
yes.
So this is about memory hierarchy. Memory hierarchy is how a computer organizes its memory from fastest but smallest to slowest but largest, which is from top to the bottom. As you can see here, the capacity increase and cost per bit and speed are decreased. Do you understand? Okay. There is some part from memory hierarchy which is register. It's smallest and faster and located inside the CPU and it operates at the same speed as the CPU. Next, cache memory, which is located close to or inside the CPU too, and it has 3 levels. And next, main memory. It is a volatile memory, which is the data will lost when the power in computer is turned off. And secondary storage is a non-volatile memory and has a large storage capacity than main memory. Do you understand about the hierarchy now?
Yes.
Okay, there's many cache design aspects, but I choose direct piping since you don't understand this part, right? Okay. It is a technique where each block of main memory is mapped to exactly one location in the cache. We call it as cache line. If the required data is in the cache, CPU can access the data almost instantly. We call it as cache hit. And if the data is not in the cache, CPU must go to the slower RAM to retrieve the data, which is we call it cache miss. Can you differentiate between these two now?
No, can you explain to me?
Okay, let me explain more. This is an example of it. In the we use direct mapping, which is each memory block is mapped to exactly one cache line using the formula as you can see here. An example, let me tell you, there is 6 block numbers you can see, and number of cache line is 4. So we use the formula to calculate it. At the beginning, you can see from here number 5 and 7 are being accessed. And we call it cache miss because at the beginning the cache is empty. So you can see here that there's number 5 again. Number 5 being accessed again, we call it cache hit because hit happened when the data that we want is already in the cache memory. And you can see here again, memory block A maps to the cache line 0. We call it cache miss since there's nothing here yet. And number 2 being accessed again, we call it cache hit because you can see there is 2 and there is 2 here again. Do you understand now?
Okay, thank you, Aini.
You're welcome.
Okay, so let me explain to you in a simpler way. So, chapter 7, parallel processing. So, first you need to know what is parallel processing. Parallel processing is a computing technique where multiple processor or CPU cores execute tasks at the same time to complete a job faster and more efficiently. So, do you understand so far?
Yes.
Okay, so we move to the next one, which is multiple processor organization. So, it's a computer system with 2 or more CPU working together. So, the main idea is to handle big and complicated tasks. So, next we move to the next part, which is SMP. So, what is SMP? So, SMP stands for symmetric multiprocessor. The SMP is a system where all CPU are equal, which means there are no master or slave processor. And all CPU share the same memory and input-output devices.
So if one CPU is more powerful than the others, can it control them?
No, in SMP, all CPU are treated the same. They all run under one operating system and share the workload equally.
Oh, understand?
Okay, so you can see the characteristic of SMP. They are identical processor, share memory communication, complex design, and expensive. Now, let's compare multiprogramming and multiprocessing. So, multiprogramming use one CPU to run many programs by switching between them. And multiprocessing use multiple CPU to run programs at the same time. The last slide is Amdahl law. Okay, so now I'm going to explain the calculation of Amdahl law. So first, this is the formula and we need to understand what is S, P and N. So S is speed up, P is the percentage of the program that can be run in parallel, N number of processor, and 1 minus P the part of the program that must run sequentially. So in this example, 16% of the program that can be parallelized, So P is 0.6 and the remaining is 14%. Is sequential. So 1 minus P is 0.4. Let's say we use 4 processor, so N equals to 4. Now we substitute the value into the formula and we got 1.2 speed up maximum. So the maximum speed up of the system is around 1.82 times. This shows that even with more processor, the sequential part still limit the speed up.